Hello, you're welcome to our class in mathematics today, and we shall be looking at the topic SOD. Now, for us to understand SOD, we need to know what rational numbers and irrational numbers are. Rational numbers are numbers that are integers, and they are capable of being expressed as the ratio of two integers. Integers like 2, 4, 5, these are integers. And we said it can also be expressed as ratio of two integers, such as 6 over 3, 2 over 4, 2 over 3. So examples of rational numbers, we have proper fractions, you have your integers, you have your improper fractions, you have your mixed fractions, you have terminating and recurring decimals. They are examples of integers. While irrational numbers are numbers that cannot be expressed as ratio of two integers. For instance, so we said these ones are rational. While if you have root 3, 3 root 5, 4 root 7, these are examples of irrational numbers. So SOD is expression of irrational numbers. So we find out that when you will be solving SOD questions, we shall be dealing with expressions of irrational numbers. We have rules as well in SOD. If you have AB, this is square root of AB, where this can be expressed as root A times root B. For example, if you have square root of a number such as 15, it can be rewritten as square root of 3 times square root of 5. 2. We have a rule which is A over B, and that is A divided by B all in square roots, and it's the same as saying root A over root B. For example, if you have 7 over 23, that's square root of 7 over 23, it's the same as saying root 7 over root 23. 3. N into this root sign, and then you have your AB. Now it's the same thing as saying n root A multiplied by n root B. For instance, if you have 81 here and you have 4 over here, it could be written as this: 27 multiplied by 3, although this is not the simplest form that you can have. And number 4, we have A over B, where we have this n inside this root sign, and then we have the n as well inside this root sign. So for instance, if you have 27 over 125, it's the same thing as this: 327 over 3 125, and the cube root of 27 is 3, the cube root of 125 is 5. So we have this. These are the basic rules that we need to take notes before we solve some questions. Alright, let's look at basic operations in SOD. When we talk about basic operations, we are talking about addition, subtraction, multiplication, and division of SOD. Addition of SOD. For us to be able to add SOD, we need to ensure that the roots have the same value. For instance, if you have A root B plus C root B, this will be possible to add. But if what we have in these roots are different, then we can't add. So an example, if you have 3 root 2 plus 4 root 2, that would give, so 3 plus 4. Then since the root 2 and root 2 here are the same, you would pick one of it. So you are left with 7 root 2. Subtraction. In subtraction, it is also similar. You can easily subtract if the the irrational number inside the root are the same. So let's say that we have a root b minus c root b again. If we have 5 root 3 minus 2 root 3, since the irrational numbers inside the root are the same, although there are times where you may have numbers that are not irrational inside, but you need to break it down to the simplest form. But in this form now, we have the irrational number in the root. So we will have 5 minus 2 first. Then root 3 is common there, so we have our root 3. So what does this give us? 5 minus 2, that's 3 root 3. Then we have multiplication of surd. To multiply surd, you could have different numbers in the root. So for instance, if you have 2 root 3 multiplied by 5 root 2, the numbers that are outside the root multiplies each other. That is 2 multiplied by 5. Then you have your root. We have root 3 times root 2. So that's 2 times 5. That gives 10. Then this is root 3 here and root 2. So root 3 times root 2, that gives root 6. So that is our answer. And then finally we have division. When we are talking about division of surd, if you have a number such as 18 root 30 divided by 6 root 5. So this as well may have different irrational numbers. So all we need to do is just to have 18 over 6, which is 18 divided by 6. Then you have your root 30 over 5. So don't forget part of our rules. These two can be merged into a common root. So 6 here 3, 5 here 6. So we are left with 3 root 6. Alright, so we want to solve some questions under surd. Question 1. Express as complete square roots. 5 root 5, 11 root 2. Now if you look at this is more like the simple form or the basic form of a surd. Now to express as a complete square root, we look for how to move this 5 into this root. Now we know that 5 is the square root of 25. So if we make it as 25 in here, which is the same thing as 5, then multiply by 5. So to make it a complete square root, we will now bring this together, just like our first rule of surd. So 25 times 5 gives us root 1, 2, 5. Let's express 11 root 2 as a complete square root. So we'll follow the same process. Here we have 11 is the square root of 121. Then multiply by root 2. So we'll multiply the 2 and that will give us square root of 242. Question 2. We have to write in their basic forms. A. Root 18, root 96, root 512. To write root 18 in its basic form. Now if you look into this root, you find out that 18 is not a prime number. And so it is possible to have multiples of numbers that would give us a square root. So if we consider the multiples of 18, we have 2 times 9 as part of the multiples. So 2 times 9 will give us 18. That is not the only multiple. We could also have 3 times 6. We can have 1 times 18. But we are using 2 times 9 because 9 is a perfect square. And so this is same as saying root 2 times root 9. Root 9 is 3. So the basic form of root 18 is 3 root 2. We want to express root 96 as a basic form. So just like we said earlier, we are going to look for the multiples of 96. There are several multiples of 96. But the one that we shall use is 6 times 16. Why? This 16 happens to be the highest perfect square that we could have there. Because we could also have 24 times 4. But when we consider this, yes, 4 is a perfect square. Likewise, is 16 a perfect square. But if we consider it closely, the biggest perfect square is 16, whilst 4 is smaller. So we'll go with the bigger perfect square. So the bigger, we'll have it as root 6 times root 16. And that will be root 6 times square root of 16 is 4. So the answer is 4 root 6. We are going to express root 512 as in its basic form. We look for the multiples of 512, and that would give 2 times 256. That's not to say there are no other multiples, but 256 happens to be the biggest perfect square to use. And so we'll have root 2 times root 256, and that gives us root 2 times square root of 256, and that's 16. So we have 16 root 2 as our answer.